All right, so moving from, that's all I got on the rotifer. Rotifer's got a mouth and an anus and kind of cute little toes. But let's move to the mollusk. I love the mollusk. I firmly believe that after we go extinct, and we will, the mollusk will rule the world. Mollusks have a basic body plan that has a muscular foot, a visceral mass, and a mantle cavity. So 3 big pieces. The foot is used for movement because, it's a foot. But it can be adapted to form all these different appendages, whether it's a single foot, like on a snail, or that foot is adapted into multiple tentacles for octopi and squid. The visceral mass has the organs, complex heart, complex brain, and occasionally complex eyes. If you think about a snail shell, I swear to you, before this class, I'm pretty sure most of you thought the snail shell was the snail's house, where it just was able to hide. That's not the way it works. The snail's organs are intimately tied into that shell. What are slugs? Slugs are, think of them as snails whose mantle cavity is on the inside of them instead of the outside. I guess it could crawl into one, but it's not like it's going to carry it with it. No, it wouldn't. Totally different body plan. Mollusks have this mantle that's responsible for gas exchange. All mollusks do. Whether they're bivalves, so clams and such, or gastropods like your snails, or cephalopods like your squid, they all have this organ inside of them, this sort of green structure that looks very feathery that allows for gas exchange. So again, feathery structure loops back and forth many, many, many times. Why does it do that? Surface area, because it allows for diffusion to happen. So I think mollusks are the next big thing. It's one of the most intelligent creatures on the planet. It's able to problem solve, use tools, and remember previous knowledge. It can figure things out. There are so many stories of brilliant octopi, it's not funny. This one, for instance, they would store the food of the octopus, because you got to mess with organisms. They took the octopus's favorite food and they put it in a jar. First day, the octopus reached into the jar, grabbed it, pulled it out. Next day, they put a top on it. The octopus looked in, tried to get it open, couldn't figure it out, but looked at that creature and wanted it. Eventually, the octopus figured out it could unscrew the jar. It took it about 3 hours. The next day, they put the jar in. Immediately, the octopus unscrewed the jar, ate it, and then actually put itself in the jar and closed the jar up. Because octopus is smart. So the cephalopods, they're not going to move like other gastropods and such. They don't creep along. They use almost a jet propulsion. They push a stream of water behind them. So when you see their tentacles go out and they push like that, it's not the tentacles that are creating the motion. It's the pushing of water through that mantle cavity, or out their siphon, to move them forward. So it's not like they're trying to swim. They're literally pushing water behind them. They have a closed circulatory system, just like you do. That means that there's no exposure of the oxygen to the exterior world. Exposure of the blood to the exterior world. They have veins and capillaries and arteries like you. And they use a heart to pump those through that, through the mantle. Now, this evolved independently. Before we split from mollusks, there was a long, long time ago, back like at the rotifer stage, there was a split between mammals and mollusks. We didn't have a circulatory system yet, so we developed this independently of the cephalopods. So it's convergent evolution. Yeah. A cephalopod isn't in no way related to a bird. No. We're closely related to birds. Cephalopods aren't. Because it has a beak. That, again, convergent evolution. Cephalopods also have very complex eyes. Their eyes are literally exactly like our eyes. But they evolved along completely different pathways, and the way they're built is using completely different genetic mechanisms. But they have the exact same function. They're able to see just like you can. Other organisms can't. They can see color, and we've actually have a lot of evidence that when they hunt using color. They change their body's color using chromatophores to match their environment. They can see what their environment looks like and then camouflage themselves. They have almost complete control over the musculature in their bodies, so that when they find a particular, I don't know, let's say they go from a very smooth rock to a very bumpy rock, they can push their skin out using their muscles to look like a bumpy rock.